Alright, hi everyone, welcome to my YouTube channel, City of Electrons. And in this video, we are going to talk about this right here, Maxwell's equation. Okay, so, but when we say Maxwell's equation, we'll come to that, okay? But think of this. If you have, let's say, a pond, okay? And it's a pond, okay? And yeah, and then it's filled with water, water, okay? Pond filled with water, okay? Of course, pond filled with water. Or maybe just anything, okay? But there's water here, okay? Pond, river, well, whatever. Now, if we throw stone or something, okay, bone or whatever, into the water, okay, we throw it into the water. Now, when this happens, when this gets into the water, what's going to happen? Okay, we'll see a splash, of course. Then after that splash, then we'll see waves, okay, or ripples, or yeah, waves. So the thing is, when we'll throw something or throw something into the water, it results or it causes waves. Okay, and of course this wave will interact with some other things around. Let's say if we have maybe something floating here, this wave caused by this object will affect this guy here. Okay, will affect this object. I hope we are following. So the thing is this: if you understand how this wave works, how this wave is generated, how this wave affects what is around, what causes this wave, how does the wave interact with other things, if you have this understanding, you can manipulate the wave to your use. Okay, you can make use of the wave. Okay, or you can make use of, you understand what I hope you get what I'm trying to say. How is that useful? Let's say funny enough, if you are standing here, okay, if you are standing here and there's an object here, okay, and you want this object close to yourself, of course you can use a stick to get the object to yourself. But before using, okay, if you don't have a stick, you can just throw something to the other side, to this end, and when you throw something here, it will generate wave, which will now do what? Push this object towards your direction. I hope you get the point. So this is just a funny application or use of our understanding of how this wave works. Okay, now the thing is this: in this video, our focus will be on electric field and magnetic field. This is the whole idea of field theory. Okay, note, I will refer back to this example I just gave while talking about electric and magnetic field. I will make reference back to this example, so bear this example in mind. Okay, so consider this thing, this object that causes the wave. Consider it as the source of the wave. Okay, and then consider the wave itself, the wave as field. Okay, this wave, let me call it water field. Okay, let me just call it water field. Those are the waves. Now, an electric field is caused by electric charge, and of course electric charge can be positive or negative based on the basic building blocks of substance, matter, electrons. Okay, so it can either be positive or negative. Now, this is the thing: the word electric field, or let me use the word field just means an area, of course. Okay, so if we say electric field, it's an area where electric force is felt. You know, these ripples we see here, or this wave caused by this object, is going to affect things around it. And this wave or this wave will have a range that is very strong. So this area, the wave will be very strong in these parts. Okay, let me use some other color. So the wave will be strong in this part, but the wave will not be too strong in this other part. The wave will not be too strong here. If the lake extends, maybe the lake is still as wide as this, we still have other as wide as this. This wave created here will not be as intense. Unless, okay, the wave will be very intense here, as you can feel the wave in this area, but you can't feel the wave much in this area. Are we getting it? So the area where you can feel the wave, where this wave is experienced, that area is the field of this. So the area where electric force or electric force is experienced, that is called electric field. Okay? The area where this wave is experienced is called this wave, or this field. Okay? So the idea, let's say if we have a charge here, and we have a charge here, an electric charge. So it looks like oh boy. So if we have an electric charge here, and we say this area now, we have the electric field. Sorry, just listen, okay? This area now, okay, we can experience or we can feel the electric force. We can feel electricity in this area. If we can feel electricity in this area, this place is called what? Electric field. Okay? If we can feel magnetic field in this area, if we can feel magnetic field in this area, if we can feel magnetic force in this area, it's called magnetic field. If we can feel gravitational force in this area, it's called gravitational field. That's the simple idea of fields. Okay, I hope we are following. So now this brings us to Maxwell's equation. With that being understood, okay, please, you can take the video, rewind, and then watch the thing over and over again. Now this brings us to Maxwell's equation. For Maxwell's equation, there are 4 of them. Okay, there are 4 equations. And what do we use these equations for? They tell us how electric and magnetic field, they behave and they interact. Okay, now I've already defined a field, saying that a field is a region, or simply a region where a force is experienced. Okay, so if we say electric field, that means that region will experience electric force. If we say magnetic field, that region will experience magnetic force. Simple as that. So for Maxwell's equation, there are just 4 equations that helps us to understand how electric field and magnetic field, how they interact and how they behave. Remember I said that understanding, you might this example and this field we have here, understanding how this field behave, how it interacts with other things. When you get an understanding of that, you can use it to your own good. You can use it to your own good for humanity and things like that. So Maxwell's equation now explains how electric and magnetic field do what, how they interact and how they behave. Now why is that important? When we know how they interact and they behave, we know how to use them. Of course, they are already in use. You know, this our wireless communication, wireless network. They are based on Maxwell's equation. They are based on lines of forces we cannot see. Electric forces passing through air, through walls. You can be inside a room and you can receive a phone call. Wireless communication. So with our understanding of how electric and magnetic field interact and how they behave, we can apply them to our day-to-day life. So this is just a simple and quick overview of Maxwell's equation. Of course, we've not written any equation, but I just want you to understand the basic concept of this before we jump into the equations. Okay, so I will stop this video here, and in the next video we'll just give a brief of what we mean by A, B, and C, and the other video will talk about the A parts. Okay, so of course, if you have any question, of course, leave it in the comment section. Like, share, subscribe, and I'll see you in the next video. Thanks for watching, and bye for now.